In this episode, we are going to talk about helium. What is helium? Characteristics of helium, history of helium, and the use or application of helium. Helium is a chemical element with the symbol He and atomic number 2. It is a noble gas, which means it belongs to group 18 or group 8A of the periodic table. Helium is the second lightest and second most abundant element in the universe after hydrogen. Characteristics of helium. 1. Abundance. Helium is primarily formed through nuclear fusion in stars, particularly during the process of nuclear reaction in the Sun. It is the product of the fusion of hydrogen atoms. Helium is present in large quantities in the Sun and other stars and is the second most abundant element in the universe. 2. Inert gas. Like other noble gases, helium is chemically inert, meaning it does not readily react with other elements or compounds under normal conditions. This makes it safe for many applications, including use in balloons and as a cooling medium in certain industrial processes. 3. Low density. Helium is much less dense than air, which is why it is commonly used to fill balloons, blimps, and airships, as these provide buoyancy. Due to its low density, helium is often used in various applications where a non-reactive lightweight gas is needed. 4. Low boiling point. Helium has an extremely low boiling point of negative 268.93 degrees Celsius or negative 452.07 degrees Fahrenheit, which is just a few degrees above absolute zero. This property makes it useful for various exogenic applications such as cooling superconducting magnets in medical devices like MRI machines and in scientific research. 5. Applications. Helium has various applications including cryogenic, cooling nuclear reactors, pressurizing and purging gas, and as shielding gas in welding applications. It is also used in some medical applications, such as helping patients with respiratory issues breathe more easily. 6. Helium-3 and helium-4. The two stable isotopes of helium are helium-3 and helium-4. Helium-4 is the most abundant and commonly used isotope, while helium-3 is relatively rare and has specialized application in certain scientific and research fields. Overall, due to its scarcity on Earth and the high costs associated with extracting it from natural gas deposits, helium is considered a valuable resource and its conservation and responsible use are encouraged. History of helium. The history of helium is closely tied to the discovery and exploration of the element and its properties. Here is a brief overview of the key milestones in the history of helium. First observation, 1868. Helium was first observed as spectral line during a solar eclipse in 1868 by French astronomer Pierre Janssen and English astronomer Joseph Norman Lockyer. They noticed a yellow line in the solar spectrum, which they initially attributed to an unknown element called helium, named after the Greek word helios, meaning the sun. Terrestrial discovery, 1895. Helium was first discovered on Earth by Scottish chemist Sir William Ramsay in 1895. Ramsay, along with English chemist Lord Rayleigh, analyzed a mineral called cleveite and found the helium in it. This marked the first time helium was detected on our planet. Alpha particle emission 1898. In 1898, two British scientists, Sir Ernest Rutherford and Thomas Lloyd, independently discovered that alpha particles emitted during the radioactive decay of certain elements were actually helium nuclei He2 plus ions. This discovery provided additional evidence of the existence of helium and its atomic nature. Production and isolation 1905. In 1905, helium was first isolated on a large scale by American chemist Hamilton Cady and American engineer David McFarland. They extracted helium from natural gas sources in Kansas, USA. Helium was found to be present in certain natural gas deposits, often associated with natural gas fields. Liquid helium 1908. In 1908, Dutch physicist Henk Camerons became the first person to liquefy helium. He achieved this feat by cooling helium gas to extremely low temperatures, just a few degrees above absolute zero. The liquefaction of helium opened up new possibilities for its use in cryogenic applications. Helium in airships and balloons, early 20th century. Helium's low density and inert gas made it an excellent choice for falling airships and balloons, providing buoyancy without the risk of combustion. This use gained popularity in the early 20th century, especially during World War I and World War II. Helium is scientific research 20th century. As the study of low temperature physics advanced, liquid helium became crucial in conducting various experiments and research. Superconductivity and superfluidity were observed in helium, leading to significant discoveries in quantum mechanics and condensed matter physics. Conservation efforts 1960s onward. Due to the growing demand for helium and its scarcity on Earth, conservation efforts and strategic helium reservation were established in various countries. The United States, for instance, created the Federal Helium Reserve in 1960s to store and manage its helium resources. Today, helium continues to be important in a wide range of applications, including cryogenic, scientific research, medical imaging, welding, and many more. Its unique properties and application make it valuable and sought after resource, leading to ongoing efforts to ensure its responsible use and preservation. Use and application of helium. Helium is a wide range of application due to its unique properties. Some of the most common and important uses of helium include balloon and airships. One of the most well-known use of helium is firing balloons and airships. Helium low density provides buoyancy, making it an ideal gas to lift these objects off the ground. Unlike hydrogen, another lifting gas, helium is non-flammable, making it a safe choice for these applications. Cryogenics. Helium extremely low boiling point makes it indispensable for cryogenic application. Liquid helium is used to cool and maintain superconducting magnets in devices like MRI magnet machines, particles accelerators, and nuclear magnetic resonance and MR spectrometers. Welding. In certain specialized welding processes, helium is used as a shielding gas. This inert gas nature of helium helps protect the welding area from the atmosphere, preventing oxidation and ensuring a clean world. Scientific research. Helium is extensively used in scientific research, particularly in low temperature physics and experiment involving superconductivity and superfluidity. It allows researchers to reach extremely low temperature needed for these studies. Deep sea diving. Helium oxygen mixtures, known as heliox, are used in deep sea diving to reduce the risk of nitrogen narcosis at great depth. Helium low narcotic properties make it a safer alternative to nitrogen for breathing gas in deep sea diving. Airbags. Helium is sometimes used in airbags in vehicles due to its non-flammable nature. Although other gases like nitrogen and argon are more commonly used, helium remains an option for specific application. Leak detection. Because helium is non-toxic, non-flammable, and relatively rare in the atmosphere, it is used as tracer gas for leak detection in various systems and equipment, including refrigeration and air conditioning systems. Rocket fuel pressurization. Helium is employed to pressurize and propel liquid fuel in certain rocket systems. Its properties make it suitable for maintaining the required pressure and stability in the fuel tanks. Breathing mixtures for deep diving. In very deep sea diving, trimix, which is a mixture of helium, oxygen, and nitrogen, is used to mitigate the effects of high pressure environment on divers. Party and events decoration. Despite the scarcity and importance of area, it is still used for party and events decoration, firing helium balloons for festivities and celebrations. It's essential to note that helium is a non-renewable resource on Earth and its supply is limited. As a result, there are ongoing efforts to conserve helium and encourage its responsible use in various applications.